Your job while watching this video is to understand the difference between ratios, rates, and unit rates, and to understand how to compute and simplify them. All right, so first, this one should be a review. A ratio compares two different quantities using division. Because remember, a fraction bar always means divide. So there are three ways to write a ratio, and the three different ways are listed right here. Important things to remember with the ratio, order is important. So if somebody asks you for the ratio of girls to boys in the classroom, then the first number has to represent girls and the second number has to represent boys. A ratio should always be written in simplest form, so that's one other thing to remember. All right, then after that quick review of ratios, I want to talk about a certain type of ratio. And this type of ratio is probably the one we most commonly use in life, which is called a rate. So a rate is a ratio. It does compare two different quantities. The only difference, the only special thing about a rate is that the quantities have to be measuring different things. So over here when we did girls to boys, all right, they're both measuring gender. We're comparing two different genders or types of people. A rate, though, compares two things that are different. In this example, it compares miles, which is a measure of distance, to hours, which is a measure of time. So that would be a rate. Then, lastly, a special type of rate with a denominator of 1 is called a unit rate. Think about what unit means. Unit means one thing. All right? So a unit rate is a rate. It is a ratio, but the special thing about a unit rate is that its denominator has to be 1. So to get from this rate to this unit rate, all right, they had 60 miles per 2 hours, which is a rate. To make it a unit rate, they found out how far that same vehicle could go in 1 hour. All right, if you're looking for a job and it tells you how many dollars, it tells you you'll earn $18 per hour, that is a unit rate because it tells you for 1 hour how much you would make. The denominator is 1. If they told you you would earn $98.50 per 3 hours, that would be a rate, but it would not be a unit rate because it's telling you for 3 hours, not 1 hour. Okay, so example 1 with rates, ratios, and unit rates. There are 45 males and 60 females in a subway car. Let's use that first for example A. Find the ratio of males to females. So males came first. It's very important then that the number representing males comes first. So there are 45 males to how many females? 60. We could also write that as 45 to 60. We could also write that as 45 to 60. We could not write it as 60 to 45 because then it sounds like there's more females than males, which is not true. All right. Now, one thing I did tell you is a ratio should be simplified if you can. So 45 over 60. We can divide both of those numbers by 15 and get 3 over 4. So while there are 45 males in the car and 60 females in the car, we could also say there are 3 males for every 4 females, and that would mean the same thing. All right, then, and that is a ratio. That is a ratio. Males to females would be a ratio. Part B, find the speed of the subway car. Okay, so we know the subway car travels 2.5 miles in 5 minutes. That is a ratio because it's comparing two quantities, but it is also a rate because the top units are measuring distance, the bottom units are measuring something different. They're measuring time. So that would be called a rate. That is not a unit rate. A unit rate, if we wanted the unit rate, we want to find out how fast that subway car goes in not 5 minutes, but 1 minute. And we will come back to that later, that part. All right, moving on. The ratio table shows the cost for different amounts of artificial turf. Find the unit rate in dollars per square foot. So dollars per square foot. Dollars came first, so I'm going to write that on top. Dollars per square foot. Okay. Since each of these, they're multiplying by 4, so if you buy 4 times as many square feet of turf, you pay 4 times as much. And they're saying if you buy 4 times as many, you pay 4 times as much. Since these are all equivalent, this is equivalent to that, is equivalent to that, is equivalent to that, you can pick any one of those and use it. I'm just going to use the first one. So dollars is this bottom line. So $100. All right, and how many square feet does $100 get you? It gets you 25 square feet. All right, we want to find the unit rate. Okay, so we want to find out not what 25 square feet cost, but what 1 square foot would cost. Whoops, I'm going to label that with feet squared because it's faster. Okay, so remember, whenever you see a fraction bar, right, that fraction bar means divide. So this lovely line right here means divide, and then we just work our way down. Top divided by bottom, numerator divided by denominator. So 100 divided by 25 equals 4. So that's our missing number. 1 square foot of this is going to cost $4, and this is a unit rate because the denominator is 1. Okay, finding a rate from a graph. Choose and interpret. Okay, let's start with this. Graph shows the speed of a subway car. So here's another subway car. Find the speed in miles per minute. So I'm going to start by writing that down. We want miles per minute, not minute per miles, miles per minute. Compare the speed to the speed of the subway car in example 1. Okay, so we'll save that for later. First, let's just find the speed of this car. So if I look at my graph, the x-axis, and remember in ordered pair, the x number always comes first, then y. Just like the alphabet, x comes before y in the alphabet. So your x number in this first ordered pair, if you prefer to choose the second ordered pair, you sure can. I'm going to go with the first. The x number is 1/2. And if I look down on the x-axis, I see the x-axis stands for time in minutes. So time in minute is 1/2. All right, the y number, all right, the second number in the ordered pair is 1/4. And when I look at the y-axis, I see that it stands for distance in miles. So I'm going to put 1/4 up here. Now this is a complex fraction. It's a fraction with a fraction as a numerator and a fraction as a denominator, but it's not as hard as it looks. Remember, we want to find the speed in miles per minute, so we want to find the unit rate. Instead of having a half minute at the bottom, we want to have per 1 minute. How fast is that car, or how far does that car go in 1 minute? So again, remember, every fraction bar you see means divide. So we are just taking the numerator, which is 1/4, divided by the denominator, which is 1/2. All right, to divide a fraction, you change divide to multiply, and then you take the reciprocal of whatever comes next. All right, we then multiply our numerators, multiply our denominators, okay, so our answer is 1/2 or 0.5. So remember, our top label is miles. So this subway car can go 1/2 a mile in 1 minute. And that is a unit rate because our denominator is 1. Now, the second part of that said compare to the speed of the subway car in example 1. So if I go back to example 1, all right, right now I can't compare. This is not a unit rate. It's telling me how fast this car goes in 5 minutes. But to compare, I want to find out how far this subway car also goes in 1 minute, just like the other one. So the other subway car in example 3 goes 1/2 mile in 1 minute. If we want to find out how far this subway car goes in 1 minute, we just do the division. All right, fraction bar means divide. So we take numerator divided by denominator, and again, get 0.5. So these two subway cars are going at the same speed. They're both going 1/2 mile in 1 minute. I would like you to try example 4 on your own. When you come to class, if your notes filled out, you should have some work that shows me how you attempted this one. I'm not grading it to see that you did it right. We're going to